Hi guys, in this video we're going to have a look at drawing histograms. Before we go into and delve into drawing histograms, I just want to do a little bit of explanation as to why is a histogram useful. Now what I've got here is a table of some values where I've got height in centimetres and different grouped ranges are grouped here. So I've got 100 to 120, 120 to 140, 140 to 50, so you'll notice it's different, and 150 to 160, again different to these but the same as this one, and then 160 to 200, which is different to all of them. So the actual grouping there is different. And if you were to plot a bar chart, you'd have something that looked a bit like this. Now the problem with plotting a bar chart when the grouping is different is it looks weird. And what I mean by that is if we compare the first one, which has a frequency of 20, and the last one, which has a frequency of 20, technically they are the same, 20 and 20. However, this bar is actually twice as big as this one here. So it gives a little bit of an unfair sort of view of the quantity of this grouping here. This one looks twice as big as this one, even though actually they're the same. Likewise, if we compare these two here, so again 25 and 25, so the frequency is the same, but again this bar here looks twice as big as this, so it can distort people's reading of the bar chart. They might not get the right feel or the right data or the right impression of what this bar chart is trying to say. So that's why a bar chart doesn't quite work when the groupings here are different. Instead we draw a histogram. So let's give that a go. So I've got exactly the same table of data here. I've got my height and my groupings. I've got the frequency. Now with a histogram, you have to work out something called the frequency density. And to do that, all you do is you take the frequency and you divide it by the class width, so the difference between these two here. So if we do the first one, I'm going to have 20 as the frequency. I'm going to divide that by the class width here, which is 20. And 20 divided by 20 is 1. So the frequency density for that one is 1. Next one here, the frequency is 25. The class width is 20, which gives me 1.25. Usually this would be a calculator paper, to be fair. All the numbers will be really easy. Frequency is 30, divided by the class width, which is 10. Difference between 104 and 150 is 10, which obviously gives you 3. 25 divided by, again, 10, which is the difference between 150 and 160, the class width, which is 2.5. And 20 divided by 40, which when you simplify is a half, and 0.5. Okay? So you work out what's called the frequency density by doing the frequency divided by the class width. Once you've done that, all you do is you plot it on the graph, where the frequency density is the y-axis and the height is on the x-axis. Okay, and do not forget to label your axes. You will lose marks in the exam if you do not label your axes. And even if you can't do any of this, and even if you plot a bar chart, always label your axes, because you never know, you might get lucky and get a mark for that even though your answer is wrong. So definitely always label your axes, and obviously don't forget a title. Now I haven't got any context to this, but it might be something like the height of a class, so just make sure you add the title as well. And like I said, once you've done this, you just plot it. So between 100 and 120, so there's my 100 and 120, it goes up to 1. So what I do is get my ruler, and make sure you use a ruler. There's nothing worse than seeing an untidy graph. So next one, between 120 and 140 is 1.25, which is going to go halfway up that square, like so. Next one's between 140 and 150, so there and there, and that goes up to 3. Like so. Next one, 150 to 160, so again just one square there, that's 2.5, so 2.5 is at that point there. And the last one between 160 and 200 is 0.5, and then 0 to 1, so that'd be the first square, like so. Okay, and that's how you draw a histogram. But why is it useful? Why is it better than a bar chart? Well, if you work out the area of each bar, so the bar area, if you actually work out each bit, the actual area, it actually equals the frequency, which makes it a lot more easier to compare the bars, and it makes it a lot more accurate as well. So just a quick example, if I work out the area of this one, the 20 is the base, 1 is the height, 20 times 1 is 20. This one here, 10 times 3, gives me 30, which is the frequency. Okay, so that's the idea of a histogram, is that the bars actually represent if you work out the area of the bars, it actually represents the frequency, which makes it a lot more easier to compare the bars. So that's how you do it, guys. Work out your frequency density by doing the frequency divided by the class width. Draw yourself some axes, plot your graph. Don't forget to label them. Cheers for watching.